in this question we are asked to find the value of this integral. So now obviously this is nothing but, so we replace the x by z and we get the, so we're going to use residue, we're going to integrate by the method of residues. So the this function f of z, which is 1 by z to the power 4, obviously has singular points at z is equal to, so this is 4, singular points at z to the power 4 is equal to minus 1, or z is equal to the minus 1 to the power 1 by 4. Now this can obviously be written out as in terms of e, this 1 can, minus 1 can be written, now this can obviously written as be in terms of the exponential So this can be written this way using the Euler's formula, and so this is written this way. Now n is any integer. So n is any integer. Now here we have, for in the upper part of the circle of radius 1. So in the upper part of the circle of radius 1, we have 2 points that satisfy this equation. So we have z1 is equal to, so pi by 4 and 3 pi by 4. Now z1 is nothing but, so using the Euler's formula again, so we have cos pi by 4 plus I sin pi by 4. So this will be 1 plus I square root of 2, and z2 okay. So now we have to find the residue at z1. Okay, so we have to find the residue. So that residue is calculated, so the residue at the two singular points is calculated using this formula, where this expression is evaluated at the limit z going to z1. So this expression now can be written out as 1 by one into z whole z cube into c, and this can be written out as minus, so you substitute z is going to z1, and you can take the you can take from the question, you can take that z power 4, we are given from here, we are given that z to the power 4 is equal to minus 1. So this tells you that this equation tells you that z power 4, so z power 4 is minus 1. So we use that and we get minus z by 4. Now similarly, we evaluated at the second singular point the residue. We calculate the residue, limit z going to z2 of the expression 1 by z power 4. So this is minus z2 4. So the integral now is two pi I into the total residue. So the total residue is nothing but you can take the minus out. So z1 by 4 plus z2 by 4. So we found out the value of z1 and z2. So we have z1 is nothing but 1 plus I square root of 2, and z2 is nothing but minus 1 plus I square root of 2. So all this comes from this expression. So for z2, you substitute in the Euler's formula cos, instead of cos pi by 4, you substitute cos 3 pi by 4, and here sin 3 pi by 4. So you will get z2 to be minus 1 plus I root of 2 square root of 2. So you evaluate this, you should get your answer to be pi by root 2. So this is your answer, and the right option is given by the option A.